Okay, class. Well, we have finished already sections 3.1, 3.2, and 3.3. Okay, and as I promised, we're going to start covering sections 3.4 and 3.5. Let's take a couple of days to cover those sections. And with this, we're going to be ready with the program that we scheduled for this week, okay, which is the first part about derivatives. Next week, starting on July 29, which is Monday, we're going to go with the second and final part of derivatives. Really, this module is a very long module. It's a 2 weeks periods of classes or lectures in this semester. So, well, this is all the material that we have for the first 3 sections. I hope you guys reviewed this already. And now, what we're going to start, covering is section 3.4 and 3.5. Okay, let me open here the lecture, and this is about, really, this is about rules. We continue with rules for differentiation. So now we are going to give you rules of how you are going to compute the derivative of the product of two functions or the ratio of two functions. And we are going to introduce also some derivatives for fundamental trigonometric functions. Really, these 2 sections is just to show you the rules. It's not going to be too long, but the most important thing is the practice that you're going to do by yourself, looking at the lecture notes and also performing your work with the homework that is already posted and will be and is already available for you guys in MyLabMath. So regarding the rules of differentiation from products and ratios of functions is as follows here in this table. Really, it's just to read the table. So for instance, if we have a function that is the product of 2 other ones, f and g, that within certain domain, they admit to have derivatives for all the points in the domain. Okay, what is the derivative of the product? Well, the rule is the following. So you compute the derivative of the 2 factors, and then you use the derivative of the 2 factors in the following way, following this expression. So it's going to be the derivative of one of the factors multiplied by the other function, as you can see here, f prime times g, plus the derivative of the g function multiplied by the other factor, which is the function f. It's very easy, okay? So for instance, here in this table, you have this example. You have this function that is the multiplication of this polynomial, which is a monomial in which the degree is 4, okay, multiplied by a trigonometric function, which is the sine function. Okay, so what is the derivative of this new function? Well, is the derivative of this one, which is 4x cubed, times this function, 4x cubed times the function, plus now the derivative of the second factor. This is the derivative of the sine function. You're going to see now in the next section that the derivative of the sine function is the cosine, multiplied by the first one. And that is the result. So very easy. But of course, I don't want you guys to memorize a lot of formulas, because at the end of the course, we're going to have, I don't know how many formulas of how to compute derivatives, how to compute limits, and how to perform integrals. You're going to get that formula as far as you make exercise. And there is something that is going to be automatic here. Once that you make 3, 4, 5 exercise of derivatives, you're going to get that in your mind. You don't need to memorize. You're going to remember those ones. Very easy. Okay? So in the case of the ratio of the two functions, the formula is a little bit complex. How you gonna make the derivative? The derivative of the ratio is gonna be another ratio. It's gonna be another rational function, okay, in which the denominator is gonna be the square of the denominator of the original function. So that's why in here, log square means g squared. And then it's gonna be, look at here, the derivative of the first function multiplied by the denominator minus the derivative of the denominator multiplied by the numerator of the original function. It's very similar to the product, but instead of having a sign plus, you're gonna have a minus sign, okay? So in here you have a couple of examples. For instance, here you have the ratio of the exponential divided by a monomial. So you make the square of this monomial, which is this one over here, 4sq squared, and then you make the derivative of the first function, the derivative of the exponential, that is itself, times the denominator minus the numerator times the derivative of the denominator, which is 3 times 4, which is 12, s squared. And that's what you have over here. Okay? Well, this is section 3.4. I don't have anything else to tell you. Okay? The rest is to make all the exercise that you have in your homework, that you're going to find in your notes, and so on. Okay? Well, this is section 3.4. Regarding section 3.5, that is the derivative of trigonometric function, what I include here in your lecture is 2 slides to remind you about the trigonometric functions. Okay? Because there are some relation between the trigonometric functions that are very useful when you're going to make your exercise. For instance, it's very important to recognize that the addition of the square of the sine and the cosine function always is 1, no matter what is the value of the argument. For all the values in which the sine and cosine is defined, that is the whole real numbers, okay, the addition of the corresponding square is equals to 1. So to remind this type of relationship are very important when you're going to make the simplification, whenever you are going to compute derivatives, limits, and so on. So that's why it's important to recognize that. For instance, if you divided this expression by the cosine, everywhere here, you're going to have the tangent square plus 1 equal to the secant square. And if you divide it by the sine, you're going to have 1 plus the cotangent square equals to the cosecant square. So it is important to remember those kind of relationships because those are useful to make the manipulation when you are going to solve the exercise. Very important as well to remember the sign of the addition of two angles equally with the cosine and also with the tangent. So keep those formulas handy because you might use those relations to solve the exercise. That's why I include this chart over here. Also, the relation of the trigonometric function with the unit circle. I'm not going to go through all the detail because this is something that you're supposed to cover. But if you have some doubts, please let me know and I will be more than happy to remind you. Okay, to remind you that. So those are kind of things that is important to keep in mind because at some moment this type of relationships will help you to make simplification that will allow you to compute some specific limit or some specific derivative. Okay, especially when we are using the concept of limit or the concept of derivative to derive some typical expression. Okay, that is very important. There are two limits that are very important here. One limit is the sine over x, the sine of s over x, when x is very close to 0. Especially exactly the same with this function cosine of s minus 1 over s when x goes to 0. Okay, you can see here that in 0, this function is not defined because you are going to divide by 0. Exactly the same with g. I put it here in Desmos, the graph of this one. And you can see that neither functions are defined 0, but the limit is 6. And the limit is, for g, the limit here is 0, and for f, the limit here is 1. So those two limits are very important. Let me just open Desmos for a moment, because what is the implication of this? Let me go, for instance, with sine x over s. Let me open here Desmos and show you something very important. Okay, Desmos graphing. Okay, so look at here. Sine over x, sine of s divided by the function s around 0 is equal to 1. So what that is telling to me? Is that telling to me that sine, the function sine and x are very similar around 0? That's the conclusion. So let's make a graph of that. So let's put it here. Let me just put here the sine function and to compare the sine function with the monomial x. Okay, so the monomial s is this line here, is this linear line, and the sine function is this one in red. Well, let's make a zoom around 0. Well, around 0, you can see that both functions overlap. So what this limit is telling to you is that around 0, very close to 0, the sine function behaves like the monomial x. That's what this is telling to you, okay? So that's why I'm showing to you exactly the same this. So one of the questions that you're gonna find in your D2L is a discussion that I put about this, okay? So now compare what happens if I have tangent of s divided by x. And I asked you to compute that limit in the discussion that you're going to have in D2L. Well, what you can see, or what you can say about the tangent, the function tangent, and the function s when we are really close to 0. How those functions behave? They are similar or not? Okay? Well, this is all what I had to tell you about this section 3.2 and 3.5. Let me go here to D2L. So this video is going to be available in D2L. Okay, and so now you have the lecture. That was the one that I showed you. There are some other videos that I suggest to watch in here. Okay, so go to MyLabMal and look at the videos for section 3.4 and 3.5. You know how to display those videos already. Okay, also, you have the notes, okay? So for section 4 and 5 of chapter 3, I include this exercise. So you can practice whatever we discuss now in the lecture with some exercise in the notes. So go through there. That is going to be, that is available today, Thursday, for you guys to work with that. And then after that, well, come back to your homework and now start working with those exercises of section 3.4 and 3.5. Okay, so I'm going to give you, as usual, as you know, I will give you a couple of days to post the keys for these notes. Okay, so but try to do by yourself first. That is going to be about section 3.4 and 3.5. The other thing that I want to mention is I hope that you already saw the keys for the nodes regarding section 3.1, 3.2, 3.3. Okay, those keys are already available in D2L. So now you can see all the details about those questions in those nodes, okay, from my side. And of course, if you have any further question, just let me know, send me an email, and I will be more than happy to reply you as soon as I can. Well, thank you guys. This is all what I had to tell you about section 3.4 and 3.5. And with this, we finish this first half of the module number 2 about the risks. Okay, thank you.